I wish I could play music without getting copyright struck. Let's rip it and see what YouTube says. Here's the YouTube. It's not gonna monetize anyways, who cares? The YouTube stream just looks so much better. Thank you. Spent this weekend kind of doing a little rebrand, making some more assets. Alrighty. Welcome to the stream. Happy Monday morning. Rise and shine. Today we got a good stream. Not too much emerging technology or latest tech news with the election tomorrow. That's kind of been taking over the news cycle quite a bit, but I still found some good stories to cover. We got Decart, which is interesting, and I have a few thoughts to share on Decart and their Oasis model, their like video game AI model, open world AI model. What's this? Then we got US regulators rejected an agreement for Amazon to buy a nuclear power generation company, which is interesting. And then if we have time or if we get to it, we'll talk about the Apple Vision Pro, because that is got set back so far because it's not doing too hot. And yeah, we'll see what else comes up, what rabbit holes we dive into. Then let's get started. Oh, that button is not working. Topic. Jesus. All right. Let me try one thing real quick. Just Twitch has like a oh, is chat not working for me? No, we're good. Chat has, or Twitch has like a marker. Yeah. Okay, added a marker just for my own sake. All right, so we have Decart, or I mean, I'm just saying Decart AI just because it adds what adds the context of what Decart is, but I'll just call them Decart from now on. But they're an AI company, just remember that. But Decart AI, they recently got funding from Sequoia. They got a $21 million seed round to bring to life this real-time generative AI open world model. But more importantly, the tech innovations they made was actually in efficiency and performance of hardware. And so it's actually a bit bigger than just like this cool model. And this model is kind of a way, just like, you know, live playing a video game without an engine, is kind of a way for them to show how performant their efficiency was that they've discovered in the actual hardware for transformers and for inference behind AI, and we'll get into that later. So let's oh, my head's cut off a little. I'm standing today. Okay, let's try and play the thing, and then we'll kind of dive deep just so we have the context. Oh shoot, that's so loud. All right. Into it. You're about to enter. It's like the movie there's like, you're about to enter a world. You're about to enter a first of its kind video model, a game engine trained by millions of gameplay hours. Every step you take will shape the environment around you in real time. All right. Okay, choose a map. And it's interesting, you actually have to, oh, my session expired, what the heck? You have to like wait because it's so performance like intensive that they can't have everyone playing at once. And it was also, we'll get into it, but this other company, Etched, is actually building a specific chip for inference. And Oasis and Decart need this chip for them to actually bring their full vision into mind because of the efficiencies that the chip will also bring on top of what Decart has created. And might have to wait here for a sec. All right, we got 4-minute wait time. Okay, well, perfect. While we're waiting, let's talk about it. Let's talk about the boring stuff. So Sequoia invested $21 million in a seed round. Seed round, if you're not familiar, is kind of like the first, round. It's, kind of like when the company's just starting out, they just kind of need money to kind of get started. Seed, small. And the two partners who invested via Sequoia, I think that's how you can kind of say it, are Dean Leitersdorf. Oh, no, that's the CEO of the company. Okay, wait, where? Oh, my notes, I need to label it better. Okay, here we go. Yeah, so the two partners who invested via Sequoia Capital in Decart are Dean Meyer and Sean McGuire. Dean is a bit newer to Sequoia. I think he joined just this year, and he's previously invested mainly in cybersecurity companies. And he also has a cloud backup startup and an identity management startup where he's served as like a board advisor since he's invested. And then Sean McGuire is a bit more experienced, been with Sequoia for a little bit longer. He's invested in a lot, and he has other AI companies on his plate. I'm kind of just mentioning that just because I feel like it's important who invests in them, especially this amount of money, because they're going to be kind of helping them get off the ground and get traction. So having experience in what they are actually, them as in Decart, actually wanting to do and go and progress towards helps, just because the Sequoia, they're going to be sitting on the board likely, and you want them to kind of bring in some knowledge besides just money, which Sequoia Capital definitely has. They're Silicon Valley venture capital veterans. So anyways, yeah, so Sean has invested in like a waste sortation AI company, which is interesting, which I think it's more of a robotics company, an enterprise sustainability analytics startup, which is also kind of cool. They allow companies to track their sustainability and like carbon output, a LiDAR company for self-driving, a chemicals marketplace, and quite a few others. So he's definitely more experienced. But I think just understanding, why or who invested at Sequoia is important, just to kind of say who believes in them with that amount of money. Been disconnected from the server. What? It's my turn. All right, let's do the village. Begin. All right, here we go. Ooh. A contest is happening in our Discord. Build one of the 3 best looking houses in 1-minute sessions to win from a prize pool of $18 million. All right, we're building a house. Kill a zombie and have rotten meat drop. So yeah, everything, I'm reading the top here, says everything you see is AI generated in real time by Decart and Etched. Etched being the chip company. Okay, I only have a limited amount of time left. Why isn't this working? My mouse is like locked. Oh. You show your cursor press escape. What the heck? Uh-oh. Their tech demo's failing. They do call us a tech demo. Which is interesting, because I mean, I feel like it definitely is. It's not like there's anything that they're getting out of this. My position in queue, oh my god, there's 3,400 people. Dang it, I really wanted to play it before I really fully talked about it. I'll wait one more time. I'll give it one more go. We just keep talking about them then. I wrote a lot of notes down. Yeah, so Decart AI is the company behind Oasis, the first real-time generative AI open world model. Decart's raised $21 million in a seed led by Sequoia Capital. The company was founded in 2023, late 2023, by Dean Leidersdorf, who's the CEO, and Moshe Shalev, who's the CPO, which I assume is Chief Product Officer. And while this is actually, while we're kind of playing a video game, this is more of just a tech demo to show off what could actually be done. Because, I mean, let's think about this. If you want to train an AI on a game like this, you still need to make the game behind training the AI. So at that point, actually what's the point, because you might as well just sell the game, and, you still have to make the game, but like to train it, you have to have people play it to then train the AI on, the model on. So at that point, like what's the point? Just release the game. And I think I have a stronger opinion just on entertainment, AI and entertainment in general, where, I feel like AI or entertainment AI is kind of like there's better problems to solve with AI right now that are actually useful. And entertainment and AI, who would, the amount of compute, as a ratio, compute to dollars to make 1 minute of something entertainment that's actually good quality that people will like is, I'm sure, astronomically expensive compared to picking up your phone and recording something or similar. Subscriptions, but subscriptions to do what, I guess, you still have to make the game and train the model. That takes long time, and we'll talk about it later, but to play a game, But you might as well, but then you might as well just give them the real game at that point, because the cost it takes to train a model like this, which you will see it's not the best, is extremely high for what you actually get. And they even said that the cost is the biggest bottleneck to actually releasing this to like consumer facing public, and I'll talk about that more a bit. All right, please work, please work. Yes. All right, we're in. If you haven't played this, it's very delayed for the fact that that's how the generation actually works. When you press W, it takes the input and then it references, you know, its model to see what then to predict next. And so it's an input to image like training. And so like I'm jumping here. Oh god, bro, I can't. I'm getting lost in the grass. It's very rough. And it looks like I actually spawned with some items, which I don't know if that's normal. I'm like right now moving my scroll wheel and it's not moving. Oh, I turned around. The village is disappearing. I'm moving my scroll wheel, but it's not actually moving on screen. There we go. I got a pickaxe. Nope. And so, you know, it's essentially playing based off of other people. So, you know, it's, you know, there's thousands of hours, I'm sure, of people playing Minecraft, and they trained the input to the video. So when you give an input, it tries to predict what is going to happen in output video screen. So as we're seeing here, you know, if we turn around, it's going to be different from what we saw before, because it's all just generated like real time. So like, you know, we started in a village and this village is nowhere to be found. There's a mountain range. Oh, wait, are these the animals now? It's like building for us. We don't even need to build because it's generating. Like, oh, we're in a cliff. Oh, we're in a sand desert now. We're in a like a little dune valley. Oh shoot, look at this look at this mountain that's generating below us, or in front of us. Yeah, this is what dementia feels like. Actually, you turn around and you're not in the same house you were just in. So let's I mean, like, and you see, like, it's increasing like this item, but I don't know what this item is. Let's try and place it down. Oh, it's a fence post. It was increasing the count of our fence posts when we were mining sand. Oh, now our pickaxe is gone, actually. What is this now? Okay, this is a fence post. Another fence post, okay. But I want our pickaxe. Oh, shoot. We just generated a cliff. Oh, I'm walking downstairs, I guess. Oh, shoot, there's an ocean. Yeah, so let's try and sprint. You could kind of see it happening. Oh, whoops. It's like I'm pressing buttons. Oh, nope, we're good. Oh, dang it, now we're in this desert. Yeah, it's impossible, right? Literally. Even to kill a zombie or creeper, punch the ender dragon. How would you even get obsidian to be able to get to the ender dragon unless it so you just happen to run into a portal that's generated? Like, what is happening, bro? This is so like fried. Oh shoot, I'm on top of a mountain now. But it's like I'm like not actually moving. Oh shit. Let's jump off. Nope, it doesn't. Oh, am I falling? It essentially has to simulate physics just based off of the, you know, what it's seen. Oh, what is this? I'm just jumping. I wonder if it's gonna bring me up. Oh, nope. I wish it said what keys I was pressing. Let's try and eat. Nope. Also, I have a piece of meat now. When did I get that? Sometimes the keys work, sometimes it doesn't. Oh, Oh, I'm back at the, I'm at a village now. Or maybe? Oh shoot. Dude, this is like one of those like memes where it's like, it transitions into like something crazy. Like, bro, I was just on a village roof. Now I'm on a, ah. Whoa. Alright, it should be ending here. Ooh. Alright, I'm gonna download this so I can add to the video. Actually, I'm curious to see what the video looks like. Let me actually look. Let's look. It looks so, it looks just, yeah, it looks exactly like it was playing. Okay, yeah, I'm glad we got that to work. So, yeah, a new era of real-time generative experiences enabled by cutting-edge AI efficiency. So the real technology and technological improvement from Decart is their efficiency, their hardware efficiency. Decart efficient AI platform provides an order of magnitude improvement in both training and inferencing, one of the largest generative models. Leveraging these advanced capabilities, Decart is able to train foundational generative interactive models and make it accessible for everyone in real time. So, you know, training, you know, is feeding it the data, processing it into, you know, bits and things that the model can understand. Inferencing is, you know, what we're just doing was inferencing. We're referencing the model and seeing what it predicts to do next. And that's kind of like inferencing. And inferencing takes a lot less compute power than training. And this is where, you know, right down here, it's like if you're training or inferencing generative models on clusters of 1,000 plus NVIDIA H100 Tensor Core GPUs, reach out, because this is where their efficiency comes, is when you start to scale, you see large percentage of improvements. And inferencing, this is where the kind of other smaller GPU players like AMD, you know, Intel, although Intel's, you know, still kind of on the come up with in terms of GPUs. This is where or just even you may not even need GPUs. You could use large like Epic or Xeon CPUs. I'm sure it's not as good, but that's where those players could come in the AI market and kind of benefit, because you kind of need the H100s, the eventual, you know, the NVIDIA's new B200s to be able to train models, because you just need so much compute power to be able to train them in an efficient and time like sensitive way. And inferencing just takes much less computing. Now, generating images is very compute heavy, and inferencing, even though it's more efficient while you're generating images, takes a lot of compute power. So this is a bit of a different case, and that's what we'll kind of get into, and that's kind of what they were able to do. So we'll read their kind of white paper here, or their like explanation on it first, and then we'll kind of dive into the press a bit. So let me take my sweatshirt off, I'm dying. All right. Oasis, a universe in a transformer. Now, let me just, before we start, there's a factory. Yes. Printer, big printer. Let's just see, just confirm what a transformer is, because they talk about it a lot. And I just want to get an official opinion here, or like official definition. What are transformers in artificial intelligence? Transformers are a type of neural network architecture that transforms or changes an input sequence into an output sequence. They do this by learning context They do this by learning context and tracking relationships between sequence components. For example, consider this input sentence: what is the color of the sky? The transformer model uses an internal mathematical representation that identifies the relevancy and relationship between the words color, sky, and blue. It uses that knowledge to generate the output: the sky is blue. Organizations use transformer models for all types of sequence conversations, from speech recognition to machine translation and protein sequence analysis. Okay. And that's and that's essentially kind of what the root of this is. It's taking an input and it's translating it, transforming it into a image slash video game output. And that's why there's a delay, because they need time to actually generate the images and predict what's going to come next. And we'll get into that though. So, all right, we're excited to announce Oasis, the first playable, real-time, open-world AI model. It's an interactive video game, but generated end-to-end by a transformer on a frame-by-frame basis. Oasis takes in user keyboard and mouse inputs and generates real-time gameplay internally, simulating physics, game rules, and graphics. The model learned to allow users to move around, jump, pick up items, break blocks, and more, all by watching gameplay directly. We view Oasis as the first step in our research towards foundational models that simulate more complex interactive worlds, thereby replacing the classic game engine for a future driven by AI. Okay, this whole thing is so loaded, and yeah. So it is inefficient, and that's that's the whole thing. But to be fair, the inefficiency is where they shine, because that is their technological breakthrough, is they created efficiencies to make this actually feasible. So, we'll dive into more of that. It's a bit at the bottom, but yeah, we'll walk through it. So an open world AI model, what? This is yeah, I just don't understand the point of, I still don't understand the point of training an AI model on a video game, because you still have to make the game to train it on, or take existing, games. And okay, and then let's even say for a second that, in essence, this is just pictures being generated really quickly. It's the same as, Midjourney or Stable Diffusion, or Sora, which is OpenAI's video one. I know Meta has a video one. I just can't remember what it's called. It's that, in essence, that's all it is. It's generating it based off of the keyboard input. So, you press W, it generates frames. So as you are moving forward, you right click or left click with a pickaxe or shovel. It, understands what that means in the context of, the world around you, and it, breaks a grass block. All that's really actually being happening are images are being generated so fast that it looks like you're playing a game, but it's just a bunch of pictures, which is essentially actually what video games, your computer is doing. It's, it's generating pictures really quick to make it look like, it's a smooth experience. And that's all they're doing in essence. And then on top of that, the model, the machine learning, the kind of neural net, whatever behind it, understands physics, the items, what they do, because they have videos, lots of images of people playing and doing that in the world. So it's essentially picking up on the simulation from a bunch of pictures and existing footage that's being mapped, from keyboard input to game, to what is happening in the game world. So it allows users to move around, jump, pick up items, break blocks. Those are all just, it inferred that from the footage and keyboard inputs of the training. Achieving OASIS requires a combination of two fundamental advances: improvement in model architecture in order to enable the model to capture the entire world and simulate it, as well as breakthroughs in model inference technology to allow users to interact with the model in real time with minimal latency. For the former, we adopted the emerging state-of-the-art approach of diffusion training combined with transformer models inspired by advanced large language models in order to train an autoaggressive model that can generate video on a frame-by-frame basis, conditioned by the user actions that at that instant. So that's kind of what I was just saying, where, you know, when you press a keyboard input, it then takes that as a context to predict and generate what comes next, and it's just generating, you know, a bunch of images at minimal latency. And you could feel the latency, like it's like pretty solid, like it's there. You could feel it, you could tell, and it's much more than like you're lagging. It's like you know, it's very delayed. It's there. And then we'll get into this, the technique they have, because I actually talked about it on stream in a different context. So yeah, we'll get to that. For the latter, we currently use Decart's proprietary inference framework, which is built to provide peak utilization of NVIDIA H100 Tensor Core GPUs for transformer workloads, and also have built the model to also support upcoming Soho chip. And we'll look into this just in a second. So let's break down kind of what's here. This whole thing is so jargon heavy with like zero explanation, because I mean, I don't know, the crowd they expect to read this probably just knows it all, but I had to look all this up, and I'm going to share it. So, two fundamental advances: improvements in model architecture in order for the model to capture the entire world and simulate it, as well as breakthroughs in model inference technology to allow users to interact with the model in real-time latency. So this is the real breakthrough that they had, is the model inference technology that creates the minimal latency and essentially real-time image generation. For the prediction part, you know, for the former, we adopted the emerging state-of-the-art approach of diffusion training combined with transformer models inspired by advanced large language models in order to train an autoaggressive model that can generate video on a frame-by-frame basis, conditioned by the user actions at that instant. So essentially what they're saying is they use the same concepts that large language models use, think ChatGPT, Claude, to predict, you know, this transform, to predict what comes next. Now, think about, you know, when you ask ChatGPT a question, kind of what we just read about here, what are transformers. When you ask it a question of text, it tries to take, you know, that text and predict what is the likely outcome in text of, you know, the next of the question that you asked or what you've said. It tries to then, you know, predict what's going to come next. That's what large language models are doing essentially. When you ask it a question or you type in something, it tries to just predict what comes next based off of what, you know, the original message that you shared. That prediction is the same concept as what they're doing here, but with keyboard input and image or video. It's the same exact concept. Now, the other week when I was talking about self-driving cars and Waymo and full self-driving, Waymo uses a similar strategy to predict traffic movement of vehicles and objects as large language models. It's essentially this similar strategy, but now they're just being applied to different generation and prediction transformer models in AI. Waymo with, you know, trying to predict objects and vehicles, what they're going to do on the road. Here they're trying to predict, you know, frame generation from keyboard input based off of a video game. ChatGPT is doing the same thing with, you know, text, you know, large language model. And so, you know, it's all kind of like, you know, they're all using these different strategies but applying it to different problems that they're trying to solve. And one important thing, you know, that OASIS kind of needs and Decart needs is this Soho chip. And let's just go take a look at this Soho chip real quick. So yeah, this is the world's first transformer ASIC. Now, if you're a crypto bro, or remember the days of kind of those ASIC miners, that's kind of like the most. I was trying to think of a reference that people might know like ASIC from, like as a context. ASIC, I feel like it was big in crypto, but for ASIC miners, because it mines only one coin, one algorithm. And ASIC stands for application specific. I'm forgetting. Application specific integrated circuit, or algorithm specific integrated circuit, which is kind of like what this is, or more so is an algorithm. So Etched is making the biggest bet in AI. To summarize, they're making a chip that is only for transformers and inference. In 2022, we made a bet that transformers would take over the world. We spent the past 2 years building Soho. I keep saying Soho. Soho, the world's first specialized chip for the transformer, the T in ChatGPT. By burning the transformer architecture into our chip, we can't run most traditional AI models. I don't know a lot of these acronyms, but the DLRMs powering Instagram ads, protein folding models like AlphaFold 2, or older image models like Stable Diffusion 2, we can't run. CNNs aren't. I don't know what any of these means. Okay, let's. But for transformers, Soho is the fastest chip of all time. It's not even close. With over 500,000 tokens per second, Llama 70 billion throughput, Soho lets you build products impossible on GPUs. Are you kind of seeing what we're getting at here, though? Soho is an order of magnitude faster and cheaper than even NVIDIA's next generation Blackwell B200 GPUs. Today, every state-of-the-art AI model is a transformer. ChatGPT, Sora, Gemini, Stable Diffusion 3, and more. Oasis. If transformers are replaced by SSMs, RWKVs, these are, I think, different, different generation AI like model generation techniques, or any new architecture, our chips would be useless. But if we're right, Soho will change the world. Here's why we took this bet. In 5 years, AI models become smarter than humans on most standardized tests. How? Because Meta uses 50,000 times more compute to train Llama 400B 2024 smarter than most humans. Meta used 50,000 more compute to train Llama 400B than OpenAI used on GPT-2. Just, take that into consideration. That's crazy. By feeding AI models more compute and better data, they get smarter. Scale is the only trick that's continued to work for decades, and every large AI company, Google, OpenAI, Microsoft, Anthropic, Amazon, is spending more than $100 billion over the next few years to keep scaling. We are living the largest infrastructure build-out of all time. This is kind of just where GPT-4 is, and kind of where it started, and it's kind of exponentially coming down. Scaling the next 1,000 times will be very expensive. The next generation data centers will cost more than the GDP of a small nation. At the current pace, our hardware, our power grids, and our pocketbooks can't keep up. GPUs are hitting the wall. Santa Clara's dirty little secret is that GPUs haven't gotten better, they've gotten bigger. The compute teraflops per area on the chip has been nearly flat for 4 years. And just think about this. Think about gaming GPUs. The 480 is essentially the 3080 that's overclocked with a bigger heatsink so it could cool it down more. And the 5000 series is probably going to be something similar. We're hitting compute ceilings, and we need some sort of innovation to be able to shrink down the chip but have it be just as efficient or, provide just as much compute power as we did before. If we get the chips any larger, one, at least for consumers, the GPUs are already insane, like in terms of size. Like we can't keep, increasing computer case sizes, whatever. Like, it's not practical. In terms of, data center and more high-end GPUs like the H100s, the new B200s. I mean, like, look at this. It's only marginally, it's like marginally more. There's definitely a calculation of compute power to the space it takes up in the data center, because we have very limited space in the data center. You want to pack it in to maximize the square footage to compute whatever ratio that they actually care about. You want to maximize that. We're kind of peaking, we're topping out right now where we can't build data centers fast enough. We don't have enough power because these things draw so much power. And they're getting bigger and that's going to result in less efficient space use in data centers. That one's just kind of, I pulled out of my ass. I don't know if that's the case. I don't know, like, actual size wise, but you kind of get the point. So this is a very real problem. There are some other startups, but they're not necessarily focusing on GPUs. They're kind of more the CPU route. And I'm sure there's other startups too that are focusing more on GPUs. I mean, Etched is one of them, but theirs is ASIC. It's very specific to transformers. So anyways, GPUs are hitting a wall. Like we're going to need a technological innovation to kind of improve. And I guarantee you, if you look at the B200s, it's essentially an overclocked H100 with small efficiencies that they've made in something like, a very low level that they're able to like eke out, probably increase cooling. There's, more power draw, etc. So yeah. With Moore's law slowing, the only way to improve performance is to specialize. And now this is the other option. You make things that are really good at one thing. You make chips that are really good at one thing, which these already exist. And they're able to be much more efficient at doing that one single thing. Now, that poses, a big challenge, especially for, if you're a data center operator, as to, the risk and the bet you take on this, like filling, essentially part of your space with, a specialized chip versus a more generalized one that you could sell to more customers. So that's kind of an interesting, dilemma. For 2022 to 2025, AI chips haven't really gotten better. They've gotten bigger. NVIDIA's B200, AMD's ML 300, Intel's Gaudi 3, and Amazon's Trainium 2 count two chips as one card to double performance. Exactly. Yeah, literally. All GPU performance gains in 2022 to 2025 use this trick except Etched. Yeah. They're just increasing the size to put more, a larger chip or more chips on it and calling it kind of the new thing. But that, comes with its own challenges. Specialized chips are inevitable. Before transformers took over the world, many companies built flexible AI chips and GPUs to handle the hundreds of various architectures. To name a few, NVIDIA's GPUs, Google's TPUs, and that's, an interesting, one, because TPUs are actually in Google's phones. They use like a variation of that in their Pixel phones. Yeah, these are all kind of specialized chips in a way, or at least AI chips. No one has ever built an algorithm-specific AI chip. Algorithm-specific instead of application. Chip projects can cost $50 to $100 million and take years to bring to production. When we started, there was no market. Suddenly, that's changed. Unprecedented demand. Before ChatGPT, the market for transformer inference was approximately $50 million. Now it's in billions. All big tech companies use transformer models, OpenAI, Google, Amazon, Microsoft, Facebook, etc. Convergence on architecture. AI models used to change a lot, but since GPT-2, state-of-the-art model architectures have remained nearly identical. OpenAI's GPT family, Google's PALM, Facebook's Llama, and even Tesla's full self-driving are transformers. And we'll get into Tesla full self-driving even more. I have a story we'll cover because it all relates back to Decart, Oasis, and Etched. It's full circle. When models cost $1 billion plus to train and $10 billion plus for inference, specialized chips are inevitable. At this scale, a 1% improvement would justify a $50 to $100 million custom chip project, which is very true. Very good point. In reality, ASICs are orders of magnitudes faster than GPUs. When Bitcoin miners hit the market in 2014, it became cheaper to throw out GPUs than to use them to mine Bitcoin. And this is exactly it. ASIC miners were kind of, big in crypto because it was just super efficient. Because, when you're mining crypto, you're essentially solving an algorithm really quick. And when you just, train one chip to do that specific algorithm, who would have thought, the efficiencies were great. With billions of dollars on the line, the same will happen for AI. Yeah, and these are kind of all the transformers. Yeah, and here's kind of just showing that, old ones and new ones are essentially the same, just with more compute, more, parameters, tokens, etc. Transformers are shockingly similar. Tweaks like Swigglue. I don't know what these acronyms are, but we don't need to know to get the point across. And rope encodings are used everywhere. LLMs, embedding models, image painting, video generation. This is what we need to know because this all relates to, what we're talking about. Image painting and video generation is both, Oasis. While GPT-2 and Llama 3 are state-of-the-art, that's what that stands for, models, 5 years apart, they have nearly identical architectures. The only major difference is scale. We believe in the hardware lottery. The models that win are the ones that can run the fastest and cheapest on hardware. Transformers are powerful, useful, and profitable enough to dominate every major AI compute market before alternatives are ready. Transformers power every large AI product, from agents to search to chat. AI labs have spent hundreds of millions of dollars in R&D to optimize GPUs for transformers. The current and next generation state-of-the-art models are transformers. As models scale from 1 billion to 10 billion to 100 billion training runs in the next few years, the risk of testing new architecture skyrockets. Instead of retesting scaling laws in performance, time is better spent building features on top of transformers, such as multi-token prediction. Today's software stack is optimized for transformers. Every popular library has special kernels for running transformer models on GPUs. Many features built on top of transformers aren't easily supported in alternatives. Speculative decoding, tree search, different algorithms. Tomorrow's hardware stack will be optimized for transformers. NVIDIA's GB200s have special support for transformers, transformer engine. ASICs like Sohu entering the market mark the point of no return. Transformer killers will need to run on GPUs faster than transformers on Sohu. If that happens, we'll build an ASIC for that too. All right. We'll end off here because most of this it doesn't, like, it's out of scope of kind of the Oasis thing, but we'll read their summarization. What would happen if AI models get 20 times faster and cheaper overnight? Today, Google's Gemini takes over 60 seconds to answer a question about a video. Coding agents cost more than software engineers and take hours to finish tasks. Video models generate 1 frame per second, and even OpenAI ran out of GPU capacity when ChatGPT signups hit 10 million users. And yeah, 10 million users, and which is just 0.15% of the world. That's kind of, an interesting ratio just to show that they already ran out of GPU capacity with such little, share of like market cap. We aren't on track to fix it. Even if we do keep making GPUs bigger at a rate of 2.5 times every 2 years, which is about what Moore's Law has turned into, it will take a decade to make video generation real time. But with Sohu, it'll be instant. What happens when real-time video calls agents and search finally just work? Soon you can find out. So this is what Decart is essentially relying on. They need this to be able to get this to the full scale of actually being real time and higher quality than what they currently have now. So, and they've already built the model to support the chip. So they're definitely leaning and relying on this chip quite a bit. So, all right, back to Oasis and Decart. We're releasing Oasis code and the weights of a model you can run locally and live, and a live playable demo of a large checkpoint. Oh, got my eyes. Which it's actually here, so it's on Hugging Face. And it's actually interesting that Etched is hosting it. I just realized that. Built by Decart and Etched. Also, I'm gonna start publishing my show notes with like links and stuff and kind of my thoughts. So I'll I don't know if I'll have it up today, but sometime this week I'll have a option. It's in the Twitch chat description under show notes. It's just empty right now, but I plan to publish them on my website. That's kind of the replacement of the newsletter I was gonna plan to do. I'm just gonna expand my thoughts a little tiny bit before stream and kind of just share them. Share them like that. Yeah, I know it will. I'm trying to, yeah, make it more friendly, interactive to people who actually want to read it themselves, because that's what I would want. So yeah, working on it. We're releasing Oasis code and the weights of a model you can run locally and live playable demo of a larger checkpoint. Today, using Decart's proprietary inference platform, that's what they're selling. Essentially, that's the product they've made. We show that real-time transformer-based video is possible and can be streamed across the web for live gameplay. When Etched Transformer ASIC Sohu is released, we could run models like Oasis in 4K resolution. Together, we believe fast transformer inference is the missing link to making high-quality, affordable, generative real-time video a new fundamental interface. So, let's break this down, because I still genuinely don't see a market for entertainment generated via AI. I just, the AI girlfriend shit, that is like, that it arguably is a form of therapy versus entertainment, because I know that is actually very popular. But besides that, I just don't understand the whole entertainment generated by AI thing still. Like, it's, yeah, not only just for the pricing it costs to generate it, but you have to remember that, like, the biggest bottleneck in us generating AI, like making entertainment by AI, videos, games, whatever, is that we have to translate our thoughts into text, and then we have to leave it up to the model to transform that text into an entire game world, entire video scene, and while the best writers are great at describing things, you would have to describe things in such detail that the effort would be crazy, and then at that point, it's hard to know if the model would even get to that point. You're leaving things up to the model to create, like the background, the you could describe lighting and such, but you're still essentially have to type an essay to get the your vision, what you're feeling, what you want it to make across, describing things in great detail in a way that the model will understand. That is the bottleneck right now, because if we could stream of thought, if we could, stream of thought, transform or stream of thought into text or feed it directly into an AI, then yes, sure, that would be great, because then we could, think things really quick, and we don't have to type it out or speak it out or whatever, and we could imagine things in our head that could then be transformed into, this fictional world. Until that is the case, I feel like I don't understand the use case for AI for entertainment. Yeah, especially when you're considering full-length movies, TV shows, in order to get consistency across that long and that many, different episodes or whatever, I don't see that really happening. And so while this is great, I don't understand the actual use case they're pushing forward. I feel like the use case is not in something like this. And if we realistically think about it, they're selling to enterprises, large companies, or startups who have funding, who could, pay for to use large amounts of GPUs, or their platform that they're kind of selling to on top of this. And realistically, you have to think of enterprise use for video generation or model training based off of video. And so that's where Tesla Full Self-Driving comes in, but we'll get to that a bit later. Because Tesla Full Self-Driving uses video to train its models on top of a few other things. But the whole entertainment for AI is just, yeah, I'm not sure if that's a good use. And this is New York Times literally just wrote an article, Friday about this, and I kind of agree, because it's not in the way that you think it is. It's in deep fake style, faces and making people look old, etc. Oh, this is Robin Wright. And that's a good use case, but for generating entertainment is just I don't get it right now. On top of it being not cost efficient to actually make this stuff. Yeah. And yeah, it's mainly in VFX, it seems like, for entertainment, but yeah, I have these. I'm looking at them later after this if we have time. All right, let's continue. While Oasis is an impressive technical demo, we believe this research is only the beginning of a new journey involving more complex foundation models that enable real-time human-AI interaction on a new level. This may revolutionize a wide variety of experiences by providing an interactive video interface that puts the control at the hands of the user. Simply imagine a world where this integration is so tight that foundation models may even augment modern entertainment platforms by generating content on the fly according to the user's preference. Or perhaps a gaming experience that provides new possibilities for the user interaction, such as textual and audio prompts guiding the gameplay. Imagine there's a pink elephant chasing me down. Yeah, and exactly. And that's exactly what I'm trying to get at. This is a pipe dream right now. More so seeing it as an augmenting work on these things. Yeah. But even then, I just the quality that it's going to produce, the amount of time and effort and money it takes to train the model, and then the actual time in compute power and money it takes to then infer, transform, use the model, I just still don't even see that being cost efficient or good time to money use right now. This, Decart is gonna help that, but yeah, I'm a bearish. Let's say I'm bearish on AI generated entertainment. And like, I just don't understand the video game thing, because you still have to train the model on the game itself. So even if it's augmenting, like the architecture would be insane to implement something like this in an actual video game outside of, the one that it's being trained on. Yeah, I don't know. I'm very bearish, I guess. All right, architecture. So this is so jargon heavy. It's kind of like, it sounds like a joke, honestly. Like, it's kind of like, what the heck am I reading? But I'll try and break it down. Hang on. Whew. No, it's freezing out and we have the windows open. It gets hella toasty in the office here, especially when my computer's streaming. Jeez. PE, literally, bro. Whew. All right. Loud hum. I could see that. All right, I think I got it. This mic is on his last stand. It's actually 10 years old come the end of this year. It's had good service. It'll go down with honor. All right, architecture. I'll pay attention to the audio bars. I feel like it keeps like peaking really high. It's just OBS though, I guess. I need to take a closer look at the audio and get it figured out. Frame it. Yeah. Right. Yeah, it's been through a lot. Out in Korea first. All right. Architecture. Diffusion models are rapidly emerging as they recently exceeded expectations and became state-of-the-art in the field of generative image and video models. So think stable diffusion. We'll get in. They explain kind of what it does, and I'll add on to it. In essence, diffusion models learn to reverse the iterative process, which adds Gaussian noise to the input, and thereby enabling generative. In essence, diffusion models learn to reverse the iterative process, which adds Gaussian noise to the input and thereby enable generating new samples given noise. Think of noise as images. That just makes it make a lot more sense. So when it gives an image, it could, generate new samples given that image. Or noise as like pixels on the screen. That's just kind of what it's referencing. This approach can be extended toward video generation by adding additional temporal layers to the model architecture that receives a context consisting of the previous frames that were generated, e.g. in an auto-regressive fashion. Let's break down what that means. This approach can be extended towards video generation by adding additional temporal layers to the model architecture that receive context consisting of the previous frames that were generated. Temporal, this is like a brain in a way, and it's using it as memory, and it's remembering the previous frame that it generated. It's storing it here in this temporal layer as the context for what it should generate next. So it's taking the previous frames, holding it, using that to predict what will be generated next. Receives, and this is the context it needs, because think about it, when you're playing a game, it needs to know what, was happening before you know, so it knows what to do, you know, on the next frame. It needs to understand the environment, the items you have, what your, you know, actions you are doing to be able to kind of, you know, continue it in a smooth way and actually make it make sense. Now, you know, you could tell it has a very short memory because, you know, if you turn around in a circle, essentially generates, you know, completely different world around you. But it's to the point enough where it kind of is smooth and feels like a video game. And I highlighted this because recent works have demonstrated that the generalization of transformer architectures beyond large language models can lead to state-of-the-art results across different fields, such as generative diffusion models. This is the same, and I referenced this before, but this is the same thing Waymo is doing with their, you know, prediction for traffic, vehicles and objects, pedestrians, trying to predict what they're going to do. It's the same concept of, you know, using the architecture of large language models beyond actual like text or large language models. They're kind of doing similar with diffusion models or image generation, noise generation, whatever you want to call it. Thus, we chose to utilize a transformer model for the noise prediction process of the diffusion training using diffusion forcing. Not sure what diffusion forcing is. Modifying the architecture to include additional temporal attention layers interleaved between spatial attention layers in order to provide context from previous frames. The diffusion is performed in the latent dimension generated by a VITV, I don't know how to pronounce that, to compress the image size and enable the diffusion to focus on higher level characteristics. In contrast to bidirectional models such as Sora, which is OpenAI's video generation model, Oasis generates frames auto-regressively with the ability to condition each frame on game input. This enables users to interact with the world in real time and not only render videos retroactively. All right, let's break this down. So we chose to utilize a transformer model for the noise prediction process of the diffusion training. So remember, transformer models, they're a way to predict what comes next. And so they're essentially predicting, you know, the noise, the pixels, the images for what comes next based off of, you know, their variables like keyboard input and previous frame generation from these, you know, layers. And the naming of it is just all so cool. Like, it literally sounds like science fiction, you know? So this temporal attention layers, think of this as just memory. This is memory that it could reference to give better context in what to generate next. And these spatial attention layers is just a different form of memory. It's trying to think about what's around it to give context to if you maybe interact with the objects around it, or for generating something, you know, based off of what's around you. So I mean, it's just, they're different types of memory that the model could reference, so it could generate an output that makes sense within the context of, you know, the video game and things around you, your inputs, the items you have, etc. That's all these different layers are kind of doing. The diffusion is performed in the latent dimension generated by VITV. We'll get into this. They talk about it a little more. To compress the image and enable the diffusion to focus on higher level characteristics. So I mean, obviously it's a lot of data, and so you need to compress it, especially since they're trying to do it real time. And higher level characteristics, visuals, maybe the physics. I'm not sure. This is kind of broad, so it's like I'm not sure what this is. And I think bidirectional models, like Sora, it's like, you know, I think the best way to think about it is like, you know, it's a line. Sora is like a line when it generates. Oasis is more like a tree or like a web, and it could take different, you know, paths based off of what the user wants to do. Whereas Sora is you know, it's more like linear. Yeah, condition each frame on game input. So that's important. You need the game input in this context. This doesn't really help, honestly. So these are the frames. This is the vision the VIT-V is the vision transformer encoder, which helps generate the frames, compress it. And the diffusion transformer, the vision transformer encoder. And, you know, this is the kind of what it predicted the frame to be based off of this input here, the user input. And, you know, in the context of Minecraft, you know, there's more, you know, we kind of saw in the beginning when we played it, but, you know, there's many keys that you have to take into consideration based off the input. So more than just this. And, you know, if more complex game, you could, you know, there could be many inputs. And remember this pattern, because this is a pattern. This all this is a pattern right here, input to video, and this could be applied to many other use cases that are actually more useful than entertainment. And that's what I'm more like, you know, bullish on versus using it for entertainment. Yeah, literally Arma. That's what I'm saying. Like, that would be insane. Like the prediction would be, you'd have to like do so much shit because of all the complexity of like you know, inventories and shit like that. So that, yeah, like, and that's kind of the complexity it could get to. And imagine that, but for real life now. You know, imagine real life inputs. You know, giant. You know, like a airplane essentially. You know. And think about it like that, you know, it could get crazy. And that's where I see this more so being useful versus entertainment, is, you know, anything that could translate input to a real life how do I say this? Input to a real life output. Input to a video output. You know, just think of that pattern, and it could be applied to different things. Tesla full self-driving, which we'll talk about. It could be similar for an airplane, you know, like UAV style drones. And don't even think of input necessarily maybe as a keyboard or a physical switch. It could also be sensors. It could be other things like that. So that's what I think that this is kind of its a potential. Not in entertainment. Please God, not entertainment. At least not right now. There's other much better problems to be solved. Performance. So this is the juice. This is where the juice is, and this is what their actual innovation and what they're actually selling. Performance. The daunting task of providing real-time inference of such large transformer-based diffusion models involves a massive effort in system-level optimization to best exploit the underlying hardware characteristics of the GPUs and servers. Current state-of-the-art text-to-video models with similar DIT, which is diffusion transformer, architecture, Sora, Mochi 1, and Runway. These are just different video generation, you know. Think of diffusion as transformer as image or video generation. These are all just different versions of that. I lost where I was. Current state-of-the-art text-to-video models with a similar DIT, diffusion transformer, architecture, can take 10 to 20 seconds to create just 1 second of video, even on multiple GPUs. 1 second. Imagine if you wanted to create a full-length Christopher Nolan film at 3.5 hours long. Arguably, maybe less. It might cost less than a Christopher Nolan 3.5 hour long Christopher Nolan film. That was a bad example. Fucking growing cornfields to show in the movie, like, all right. While the field of traditional LLM inference has developed a plethora of open source kernels and techniques, we found that the vast majority of these public techniques were less relevant to our target model architecture and thus led to either low utilization of the underlying GPU architecture or redundant operations. Therefore, we instead relied on a proprietary optimization infrastructure developed by Decart over the past year and deployed it towards a widespread effort of the acceleration of all the underlying operatives used as part of the model inference. So this is their technological innovation. This is what they're selling, is their efficiency and performance that they're able to squeeze out of existing GPU architectures, kernels, techniques. Like, this is what they're selling. This is what they actually made. Therefore, we instead relied on we got that. We found this to be beneficial for all kernels from basic PyTorch primitives, PyTorch being a Python framework for machine learning, that we accelerated drastically to the more advanced combinations of operations. In addition to this extensive effort to optimize the GPU utilization in the kernels that impact the critical path of the image generation latency, we also optimized communication primitives developed by Decart to best exploit the server architecture beyond the GPUs. NVIDIA NVLink, PCIe Gen 5, NUMA, etc. These are technologies that allow the GPU and the rest of the computer to communicate with each other in order to further reduce the latency. These strategies enable us to scale beyond inference on only a single GPU to real-time multi-GPU inference while minimizing potential bottlenecks that may arise when introducing communication that is beyond intra-GPU data transfer. So essentially, they made the process more efficient and performant to communicate between multiple GPUs and other parts of the computer, mainly though the GPU, that allows them this lower latency. The efficiency and performance that they created allowed them to have this near real-time video game generation. That is their technological breakthrough. And so just frames per second, this is the efficiency that they've created. This is Sora, which is OpenAI's, and these are the other two models, like popular ones, big ones, only ones, I don't know. And this is what they've created. This is the efficiency they've created. So it is a lot, and it is like a real breakthrough. Now, is this something that a big tech company though can't put money towards and figure out? I think that they can. I don't know how much research or what happened, but I think that's kind of the problem that I would be afraid of as Decart is, do these even already maybe exist to some point within Microsoft, OpenAI, Amazon, Google? Because if that's the case, then they would be flocking toward, this would save them so much money that they should be flocking towards Decart, throwing money at Etched to make the Sohu transformer ASIC GPU. So I don't know. Yeah, it's an interesting to think about kind of their strategy, or what would happen if a big tech company kind of created the same thing. And efficiencies like this are, thinking about it more in like the developer market. There was a group a while ago, years ago, who came out and said that they will increase the efficiency of Python by like 25% or 30% or something crazy, which would result in lots of money saved, because a lot of big tech companies use Python for, something, and that would essentially result in money saved, like direct money saved, and they could almost take that bounty and go to big tech companies. They could go to Microsoft and Google, Facebook. Instagram was built on originally Django, which is a Python framework. Dropbox heavily uses Python. Everyone uses Python nowadays. They could go to these companies and, like, as a bounty, be like, hey, is it worth it for $1 million for your stuff to run 30% more efficient? Like, would that save you $1 million? Probably. And so I feel like Oasis, or not Oasis, but Decart could be doing the same thing, but yeah, I don't know. It's like, it's an interesting like, to see what they're going to do with it and who their customers are actually going to be. Overall, this extensive optimization effort by Decart was crucial for the introduction of real-time inference for diffusion transformer models that are capable of modeling more advanced mechanisms compared to previous models. This accumulates in 47 millisecond inference time per frame and only 150 milliseconds per iteration for training. However, to make the model an additional order of magnitude faster and make it cost efficient to run at scale, new hardware is needed. Oasis is optimized for Sohu, the upcoming transformer ASIC by Etched. On NVIDIA H100s today, the model can run at 360p at 20 FPS. Not doable for production. Sohu can run the same model at up to 4K. Now that's loaded, because 4K at 60 FPS, 30 FPS, 20 FPS. I'm sure you could find a balance, but that performance efficiency from essentially the top, or one of the top AI, GPUs, one of the most powerful GPUs right now, versus the Sohu, ASIC trained specifically for transformers, like, this is a big jump. In addition, Oasis's end-to-end transformer architecture makes it extremely efficient on Sohu at the same price and power consumption as an H100 GPU. Oasis on Sohu can serve 10 times more users. We believe the price of serving models like Oasis is the hidden bottleneck to releasing generative video in production. That is, the price is their bottleneck right now. Now, again, that's a bit loaded statement, because there's a lot more to consider, but yeah, the price is the bottleneck, and there's different ways to approach that. They're approaching it by, making it more efficient to cost less, so they could then serve it at lower prices. I'm sure you could increase, kind of go wide or deep and wide, or, shallow and skinny. I'm saying it wrong, but throwing more compute power at it would be one option. They kind of want to go the more efficient route, because realistically, you can't get these GPUs, H100s, and the fancy GPUs, and they're hell expensive. All right, future explorations. With these many new exciting results, there still remain a few aspects of the model that can be improved. In certain situations, the model produces hazy outputs for recovering, which, we saw that, like, it's a little rough. Improving the memory of the model so that it may recall details from many frames back. That is those different temporal layers, spatial layers, increasing that memory. Increasing, how much it could store, so it could... so when you turn around, it's not a different world behind you. Providing an initial image outside the distribution of the model can lead to unclear results. That's interesting. Providing an initial image outside the distribution of the model can lead to unclear results. Following an in-depth sensitivity analysis on different configurations of the architecture alongside the data and model size, we hypothesized that the majority of these aspects may be addressed through scaling of the model and the datasets. Therefore, we are currently developing this direction alongside additional optimization techniques in order to establish such large-scale training efficiently. Furthermore, once these large models are developed, new breakthroughs in inferencing technology would be required in order to ensure a sustainable latency and cost trade-off. So they still need a technological breakthrough to make sure that this is good in the long run, that you could build a business around it essentially and it be cost efficient, for the time being. So there's still work to do, but they are definitely pushing the boundaries, and I like that they actually created a real efficiency and technological breakthrough. Now, they are very heavily relying on etched Soho GPU. Jesus, I keep saying Soho. So that's a big bet, but I still think that this could be good in the long run, especially if they're gonna take this to larger tech companies for efficiencies. Like that's real. That's a real a problem they solved. Let me look at my notes here. So yeah, what is the larger trend here? I said the larger trend is that extremely specific AI models solve problems much better than generalized ones, especially when moving out of the LLM world and into other model types. Because I think right now we're kind of throwing LLMs at problems that should have its own AI model, or LLMs like ChatGPT are not the best way to approach the problem or solve that problem. And I think moving outside of that, because we could essentially use input to video or image to generate fictional worlds like this, or train models on it, and it's more specific than trying to do all of this or simulate things via just text. And we kind of are going to start, we're already seeing with Oasis like more specific models for problems like stable diffusion, or taking a Sora or image generation one and trying to force it into something like this. Instead, they made their own model on keyboard input to the game specifically for kind of use of this. I don't know. Yeah, and then I kind of took the quote though that that I highlighted. Recent works have demonstrated that the generalization of transformer architecture beyond the large language models (LLMs) can lead to state-of-the-art results across different fields, such as generative diffusion models. The same predictive type of models, like how LLMs use to predict the next word, are kind of becoming a trend outside of LLMs. Waymo, I talked about Waymo use similar predictive abilities that LLMs have for predicting traffic movement for vehicles and other objects. And Oasis and Decart and Etched are kind of doing the same thing, but just for keyboard input into video game or image generation or video generation. And I kind of gave my spiel on entertainment again, where like this seems to be like they're selling it as big generative video for entertainment, and I feel like entertainment, while eventually will be a good use for AI, should be one of the last to benefit from AI, as there's real problems to be solved. Instead, I just think also like in terms of a business, like while first mover advantage is important, when there's zero market and it costs insane amounts, like why would you want to be doing that now? Like you'd want to wait for things like Decart to be more production ready, stable, cost efficient, to kind of start building on top of, unless you're actually making the things that you could sell as pickaxe and shovels like Decart's kind of doing behind the scenes. But like realistically, I don't know. I'm just so bearish on entertainment AI right now. Yeah, and also, the other week, we kind of looked at the different Goldman Sachs's prediction on the different phases of AI being developed and rolled out, and who benefits in the different phases. Right now we're kind of in the pickaxe and shovel phase with Nvidia and the chip developers making, kind of benefiting the most. This, Decart falls into that a bit, but the tools that they're creating, or the what they're trying to sell, is more so a later phase, a phase that would be benefited like much later: entertainment, video generation, video games, self-driving vehicles, things like that. Like that is much later phases that'll come to fruition, where the actual end user corporations will benefit. They're still not quite there yet, and especially entertainment is going to be the last phase. It's going to be way down there for like who benefits. Yeah, I said I foresee entertainment being one of the last. And yeah, again, partly because of the money. Who would pay who would pay for AI generated slop? Because let's be real, the entertainment that they're going to be generating is slop. it's Five Nights at Freddy's, but we're in a spaceship in a different galaxy, like that's some slop right there. Skibbity toilet, AI generated skibbity toilet, that's some slop. Yeah, and the compute power to cost ratio involved in making something would be, especially something actually entertaining, actually someone would watch. Yeah, people love slop, exactly, but the ad dollars on that slop are not going to be enough for what it's going to cost to generate that slop. Yeah, like I just feel like, and especially if you want to make something that's passable as like not AI and like actually good, like a full-length movie or a TV show, like that we have a while for that, and it's going to cost a lot. Now, I'm just thinking about this. I have seen several AI generated videos though in short form, like shorts, of cop chases that are ridiculous in that they literally look real, but then you see all of a sudden hands, and the hands are like, it looks like they're like this, like I don't know, looks like fake, and then something ridiculous happens, but it's hard to tell until that comes in. Now, like there is an argument there, but like that's slop. That's slop. Yeah, brainwash kids at least. Yeah. Yeah, then if we're okay, let's just talk about video games now. Only video games, because that is like I just can't understand the economics or the idea behind making a video game, then having people play it for thousands of hours, collecting that data, then going and then paying to train a model on that video game so then people can play the fake game via AI. I'm not really following that one. Yeah, you just, I don't know, you still have to make the game, so just make the game and then just sell that. Like I don't know, I don't really get that one. Like that use case is not, that one is not computing for me. And how I actually originally found this, what was going on, is I just happened to open up Twitter and I saw this tweet that Tim Sweeney of Epic Games replied to. Wow, everything about this sucks. He's like, let's check back on this one in 5 years. And this is the guy who at Sequoia, who kind of is the partner, like invested in them. Like, so like with no game engine, like, I don't know, there's just so many different like questions that don't make sense about this. So yeah, I just think it was funny. Yeah, I mean, then I don't know. It's a tech demo, so whatever. But yeah, I don't know. I think their use in uh for game generation for video games without an engine is like the worst. Like, why? Games are already becoming soulless from big tech companies. Like, why would you actually literally want to make them essentially have no skeleton now? The soul's already gone. Now there's no skeleton. The game engine, the game framework, the code behind it. That's why indie games are taking off. Yeah, so yeah, essentially, I guess let's summarize. The real breakthrough of Decart is its temporal attention layers and its spatial attention layers, essentially using these memories to allow it to kind of remember the context, making it more like a web in a way, or a tree versus a bidirectional line, for predicting and generating video images and frames and images or videos or images slash frames in a game, whatever. And its efficiency in its transformer and inference for like from hardware. Increasing this performance at the systems level in communication between the GPUs and the communication protocols themselves, like the NVLink for inner GPU communication, PCIe for rest of the computer CPU memory, to the GPU communication. That's where they their innovation came from. The benefit of better performance and efficiency in speed for communication between different hardware results in, you guessed it, faster generation, which results in cheaper compute power for the same thing. Yeah, or in the case of playing a video game like Decart's tech demo, lower latency, higher resolution, and increased frame rate. That's kind of what they're selling in terms of this. That's what their efficiency performance benefits translates to in terms of this, their Oasis model here. Yeah, then when you translated to more specifically generated video and images, is the same. It's higher resolution, it's faster generation, and more efficient on the compute side, which costs less for it to generate. And as a business, again, they're selling the fact that you could use the same hardware but serve more users, which results in better bang for your buck for the compute power, and more money for serving more users. And they said it themselves, the cost of using this is their biggest bottleneck, or the cost of video image diffusion generation is their biggest bottleneck to kind of serving this to more consumers. And also, it's interesting that they are very heavily relying on etched new transformer ASIC GPU Sohu. Like, they're definitely relying on that for their future, in terms of business, being able to serve a lot, like their efficiencies better. And then the kind of last thing is that they still need breakthroughs in transformer technology and inferencing technology to make this kind of their full business plan, their full picture, their full vision kind of come to fruition and come to life. So I'm sure that they're going to continue to iterate on this, and it'll get better over time. But I don't know, like Sean said, when the partners at Sequoia give it 5 years, but we'll see. We'll see. And yeah, so that kind of summarizes kind of my thoughts on Decart and Oasis. We're going to transition to something that very much relates, I believe, to Decart, talking about Tesla full self-driving, because the Wall Street Journal conveniently just released an article essentially saying that they need technological breakthroughs to be able to bring Elon's vision of robotaxis everywhere, which is, their full self-driving. They need a technological breakthrough to actually get that fully fledged out and deployed in is the short amount of time that they claim that they can do. But yeah, that's Decart. This is Oasis. If you're watching on YouTube, the links will be in the description if you want to check this out. And then I'll get the show notes figured out for stream viewers. All right. Dang, that was long. That was like 2 hours. Oops. All right, I already downloaded this. Go get some water here, and then we'll jump into the story. And I just have this, and then maybe I'll cover everything today. I don't know. I'm feeling motivated. Been enjoying streaming. I just like talking like this, even if just here listening, Austin. Which I appreciate you showing up, but I really enjoy this. So, all right, I'm gonna get some water, go to the bathroom, move around a bit, and I'll be right back. Oh god. Wrong pipe. All right, let me get close all of these. All right. Is that button not working? All right, this is essentially the thought I had, and then it was convenient that there was this article written. But I was like, I wonder if the tech Decart can improve the training or inference process of Tesla's full self-driving, since Tesla uses video footage, essentially lots of pictures, to train their models. It seems like the patterns between a game and video footage would be very similar, especially considering that, you know, there's inputs like pedal, steering wheel, blinker, headlights, etc. in a car, and then, you know, that translates exactly to the video footage and the actions that the user takes when they do that. Just seems like the patterns are very similar. And Tesla, you know, they don't just use video footage. They do have some specialized cars that they drive around on their own, like Google Maps style, and with like different sensors and LiDAR sensors and radar and etc. And they then collect that and kind of use that to help train it. But you know, they're more, the way they collect most of their data is kind of similar to this, and it just seems like it's a kind of similar pattern that could be, you know, benefited. But what are these? This is what Twitter essentially is nowadays. Like, I need to start using Blue Sky more. I literally hardly even use this to begin with. I mainly use it just to tweet my jokes. That's my benefit of this. I was trying to use it more because it, you know, in the tech world, actually people kind of do use it, but like it's just so bad. Like, yeah. Anyways, whoops. All right, let me change the topic because I want to remember to do that. Robotaxi's one word? All right. Why Elon Musk's robotaxi dreams are premature. Tesla is pushing to build true self-driving vehicles by 2026. The way its CEO wants to do it seems risky. This is actually kind of a cool graphic too, because this is the Uber one. Like every dream is, yeah. I mean, he's like, he overpromises and then underdelivers, especially on its timeline. His timeline, it's just never realistic, and he's just like saying things. Yeah, I don't know. The only thing that he's actually been kind of delivering on is the rockets and SpaceX, like that he has, but like with Tesla, which is crazy. Tesla's a public company. Like you can't willy-nilly say shit like that, because, you know, you have to back it up, and like you can't just lie. Yeah, SpaceX, exactly. Like that's the one that's actually, you know, doing what he's saying, but you can't just willy-nilly say shit. Like you have the SEC to, you know, you have shareholders who you're, you know, you have a fiduciary duty to. So, you know, you can't just sling shit like that. You can't just say shit like that. So, yeah. And this is what the article kind of says. They're saying that like he's overpromising, and in order to kind of meet what he has already overpromised, he's doing things in a way that's kind of not efficient. And as we've seen, you know, the full self-driving has been in many accidents and has many incidents, people dying, etc. Yeah, they talk about this. But this graphic's kind of cool because this is like Uber, and remember, Uber had their whole entire self-driving thing because they hit someone and killed them, I think, you know, with the driver at the wheel, I think, even, and then they kind of shut that down, which now Uber is partnering with Waymo to get them. This may be that version, I don't know. Then we have Tesla, the robotaxi. Then this is the early Waymo. This is what Waymo looked like when it first kind of started, is there these little cars. And then this looks like the Cruise. They're one, but It could also be reference to this cyber taxi that Elon's doing, and then we have their new cyber taxi. So anyways, I thought that was just a good Daniel Hertzberg shout out. All right, Christopher. I was reading this, but I was looking at this. Jesus Christ. Elon Musk is betting that robo cars will propel Tesla into a lucrative new era, but he's going about it all wrong. Musk's plans center on what he has called end-to-end artificial intelligence. The plan is to deluge Tesla's AI systems with footage from existing Teslas in the expectation that algorithms running on huge supercomputers will learn how to drive safely. That sounds familiar. Sounds like what Decart's doing, but with, video games. He hopes this will make it possible for Tesla to deliver fully self-driving cars faster and more cheaply than his competitors. Existing Tesla owners would get access next year. Next year is in, less than 2 months. Granted, I'm sure it's later quarters, but still. And newly specially designed robotaxis would be ready in 2026. The breakthrough AI Musk's dreams contrast starkly with the approach of other companies pursuing autonomous vehicles. Waymo is the industry leader, already operates commercial robotaxis, and just announced a $5.6 billion round of financing. Waymo, which is owned by Google's parent company Alphabet, also uses lots of AI, but its approach is to break down the problem of self-driving into more distinct tasks with more input from human engineers. Waymo is using data from more sensors, including lasers and radar, which give the company's cars much richer view of the world. And it's breaking down the task is kind of what I was describing before. Waymo breaking down the task where it looks and tries to predict different parts of the world around it to feed it into kind of the AI, the machine learning system of what to do. with different sensors, a more variety of ways to interpret the world around it. In the simplest terms, Musk's vision for Tesla is about an AI system that learns by watching people drive. Waymo and others are teaching their vehicles by correcting them as they do the driving themselves. So this is like more of a neural net type where reinforcement training, it's called, I'm pretty sure. Where like if you do something wrong, you tell them that's wrong, and then they're like, okay, I know now not to do that again. Musk's bet hinges on the current state of AI technology reaching a level of sophistication that it hasn't yet achieved and may not for some time, AI developers say. Let's just see what this is. This AI pioneer thinks AI is dumber than a cat. It's actually, okay, it's interesting. It's written by the same guy. So I'm just going to go down a quick rabbit hole real quick. I just want to see. Okay, he's a technology columnist. What is AI best at now? He writes about AI a lot. He doesn't really use Twitter much. But all right, he seems reputable. I was curious what this guy's background was. I mean, you have to be somewhat reputable to write for a high profile news organization. Musk robotaxi promises. Okay, just making sure my mic's not humming either. One of Musk's robotaxi promises. One of Musk's defining characteristics has been an ability to start with a goal in mind and work backwards to the solution required. With self-driving tech, his goal is a system affordable enough to put on almost any vehicle. That's a good point. That's not a bad way of solving a problem. Start with the end result and figure out how to get there. That's, Now, in something like this scale, though, it's crazy because Elon Musk may be able to do that because he has infinite resources, but you know, most other companies and individuals are not afforded that ability, privilege, dare I say. You know, and you know, I think of like a startup who has to be so much more scrappier. They have way more constraints and limits on what they do, and they have much more on the line, because if they don't do it, their company's, you know, toast. And you know, Tesla could kind of take these risks because they have infinite resources behind them, i.e. Elon Musk, and you know, the thousands of employees, etc. So I don't know. Yeah. Anyways, Musk has said robots and self-driving cars could propel Tesla's market value to at least $30 trillion. I think the world economy is like $100 trillion right now. So, yeah. Supporters of this plan point to success his companies have achieved by drawing outside the lines, like the radical reduction in launch costs at SpaceX, which now dominates the rocket business. I mean, yeah, that's the only one you could point to, though. Maybe the Boring Company with tunnel boring, when tunnel doing, like, I think there was some innovation there, but like, what's kind of come of that? He has Neuralink, which is making progress, but there's plenty of other startups too that are doing the same thing that I don't know if he's like the leading there. SpaceX is the only one I could think of. Twitter, which is a dumpster fire for multiple reasons, like that is not a, you know, he has XAI with Grok, but like it's literally like, at least right now, it's who's using it, like I don't know, like it's good because it's the cost efficient alternative, it's the cheaper alternative to OpenAI and Claude and Llama. Even, I mean, Llama's free technically because it's open, quote unquote open source, but SpaceX is the only one, you know, right now at least. I'll give him that. Musk has a long history of overpromising and being vague about how exactly his ideas become reality. He uses names for Tesla's driver assistant technology, autopilot, and full self-driving that imply more capability than it has, and Tesla has missed all prior targets for the release of fully autonomous driving systems. Also, this is beyond this. I'm kind of just thinking out loud here, but Wall Street Journal definitely hates Elon Musk, and they definitely have a bias to like smearing Elon Musk. And you know, Wall Street Journal like arguably leans right because they talk about more financial stuff and like things like that, and like, you know, their audience in their opinion section is a cesspool of conservative ideas. Like it's so bad, but they actually are very they know, like, they are still on top of like more progressive ideas, I will say. Like, and progressive is very loose, I'm using that loosely, but like they don't like Elon Musk. They're Ben Pershing, I read their the Wall Street Journal's like daily brief, he does not like Trump. But they definitely don't like Elon Musk either. There was literally like some other like Elon Musk hit piece that they released that was like, it was Putin. Elon Musk like talking to Putin, and like it was a hit piece. It was kind of a bit of a nothing burger, but like I don't know. Anyways, it's such a side tangent. At Tesla Robotaxi event this month, unveiling an under $30,000 Cybercab model with no steering wheel or pedals, Musk quipped, "I tend to be optimistic with timeframes." That's one way of framing it. He predicted production would start before 2027. By Tesla's earnings call just days later, he was saying confidently that large-scale production would happen in 2026. That is such a crazy thing to like just say. Because think of this Cybertruck, bro. That thing took forever to get to market, and like they're slowly rolling it out. And it's not even as good as they originally said. Musk and others who have worked on Tesla's self-driving tech have said its advantage is vast amounts of footage of real-world driving captured by cameras. built into all its vehicles, including all the time people have spent using the company's existing full self-driving, quote, supervised driver assistant software, usually shortened to FSD. Training Tesla's AI using this passively recorded data requires a technique known as imitation learning. In essence, to gain any advantage from all this data, Tesla's AI must watch those millions of hours of human driving and try and copy their actions, says Timothy B. Lee, a computer scientist who writes at the newsletter Understanding AI. It's like living millions of lives simultaneously and seeing very unusual situations that a person in their entire lifetime would not see, Musk said at the Robotaxi event. Tesla's backers expressed confidence that its self-driving work is better and more extensive than maybe publicly apparent. This is just copium. This is just them trying to cope with the fact that Elon Musk is over-promising and under-delivering. That's what I read this as. They're like, no, behind the scenes, it's way better, dude. Like, no, it's way better behind the scenes. Like, you don't even know. But, you know, going back to the actual AI training and kind of the point why I want to actually cover this article, this is essentially the same exact thing that Oasis is doing when trying to predict, you know, play the game. They trained it on thousands of hours of Minecraft, people playing Minecraft based in, you know, and took their inputs to translate it to the outputs, and it's the same exact thing. They're taking, you know, millions of hours of driving, and then they want the car to essentially translate that to, you know, the environment around it. Think of the temporal layers and spatial layers, you know, that kind of technology. Tesla's doing the same thing with their, you know, full self-driving, where they need to take it, you know, their spatial awareness around it, feed it in to try and predict what to do next based off of the millions of hours of human driving. You know, the millions of hours of footage for human driving. It seems like the same concept to me. Like, it seems very similar, the patterns. Tasha Keeney, director of investment analyst at ARK, which, you know, ARK is, you know, they bet heavily. They're betting heavily on Tesla. We'll say this. Whoops. What it is? Jesus Christ. ARK Invest. I just like blind clicked that. It could have been, what if that was a bad website and I just showed it. You know, they have their ARK ETFs that I previously owned. I don't anymore. But they're big on emerging technologies and everything, which is cool. And they are heavy believers in Tesla and have, you know, they have money on the line. So like, obviously they're going to try and be more in favor. I feel like, you know, like there's just a built-in bias, but yeah. Tasha Keeney, director of investment analyst at ARK, which has long been bullish on Tesla. Yes, because, you know, they believe in Tesla. Bullish is up. Bearish is down. That's the way I think about it. Think about the bull horns, point up. Very bullish on Tesla, says Musk's company may be keeping many of the technical details about its system secret, but that behind the scenes, it's continuing to innovate its AI techniques. I mean, yeah, to some degree that is true. You know, like I doubt they're fully, you know, giving things out. They're more leaking it out to get, you know, testing and beta testers and stuff. And obviously they're going to continue innovating their techniques, like, I don't know, like that's like, to me, that's just kind of like common sense in a way. Like, they're going to continue to improve and iterate. I'm sure behind the scenes they're doing things that haven't been shown into the public, but like, how much more improvement, how much better is it actually? I don't know. That's kind of the question. And they seem to believe it's much better, way, like, you know, a lot better than what it currently is. I don't think it is. I think it's more marginal. But yeah. She recently co-wrote an analysis of Tesla's robotaxi strategy that argues by 2029, robotaxis will account for almost 90% of the company's enterprise value and 60% of its revenue. By then, she says Tesla will be worth about 10 times its current value, which is around $800 billion. This is the size of, you know, Google. This is the size of like Microsoft. You know, Microsoft's like $1 trillion. Apple's $1 trillion. Nvidia $1 trillion. You know, they're saying that they're going to get to that size just off robotaxis, essentially. That is very optimistic. $2,600 per share. Like, we're talking Amazon level, you know, money. Like, Tesla's already overvalued in general, and they're overvalued based off of the future projections. So like, if you're saying now even further future, this is it, you know, like, I mean, come on, like, look at this expected bear. So this is like, if things don't go to plan, like, you know, it's 2000, bull 3100. Like, come on, this is so optimistic. And like, again, ARK has, you know, they're invested heavily in Tesla. Like, they want this, they need this to come to fruition, you know, to kind of be right and to get the payoff. I actually haven't looked at this. This is interesting. I love reports like this. I love these things. This is what I want to kind of like do. I want to make my own like this, you know, like, this is awesome. Just like predicting how things will go. No, I don't know, like, you know, these like like this money's like, this stuff is kind of whatever, but like, I like, you know, forecasting and talking about what the future could be like. I feel like that's what I kind of like to do, like on the stream, you know, talk about Oasis, what it could be applied to. Yeah, here we go. And so this is actually interesting, and they talk about this later, but oh yes, I was trying to get to this. This is the stat I wanted to get when I talked about Waymo before, where it's like, this is per crash. This is oh no, this is a little different, but essentially it's like how much human interaction actually needs per mile of driving. Five times safer than human-driven Tesla, as shown below. Miles per crash. Yeah, this isn't, the miles per crash might be good now, but it could be like so loaded. Which are available. Should I request this data? It says available upon request. I'm after the stream, I'm gonna email and request the data. But I don't know, because this may prove that it's safer, but this isn't full self-driving. I'm sure you have to consider the human interaction, like how much of this a human had to be you know, had to get involved to get it out of a tight situation or something similar. That is the better metric to actually talk about when, like, you're comparing the different self-driving models. Because I don't know about you, I haven't heard of Waymo's, you know, veering into you know, freeway barriers and, you know, cars bursting into flames in Waymos. Like, I don't know. Now I'm being a bit hyperbolic, and like, you know, again, like, you should consider the data, like, be more analytical. But, and again, Tesla's in the news a lot. They, you know, they're a bit more have a bit bigger eye on them, so that could also be the thing, you know. Maybe the Waymo headlines just aren't as big, but yeah. Anyways, I'll save this for later. Tortoises in the race to self-driving. In contrast, Tesla's competitors have trained their self-driving systems in the real world by putting a safety driver behind the wheel of the car, who takes control when the vehicle does something undesirable. These companies meticulously track those, quote, disengagements and feed the data back to their engineering teams, who tweak the system so the mistake doesn't happen again. And this is what should be considered when we're saying which full what self-driving system is like the best, because like, ideally you don't want a human there, and so if the human has to engage a lot, then that's kind of a problem when you don't have a human in the driver's seat. That approach is more labor-intensive, time-consuming, and expensive, but Waymo and others feed the data into more powerful and ultimately more reliable systems through a process known as reinforcement learning, says Lee. Research into these two approaches has shown that the difference can be wildly different. Systems trained primarily with imitation
Imitation learning, such as Tesla's, can fail when their own actions take them too far outside the realm of the data they've been trained on. In addition, Tesla's devotion to a fully end-to-end AI system creates a black box of tangled connections in which it can be impossible to understand why the system does certain things or how to correct those behaviors. That's also a very important fact. And it's kind of like think about like an algorithm that was developed that you could then go and like reverse engineer to how it works. You can't necessarily do that with the way Tesla creates their systems, because it's kind of just an amalgamation of different video to footage translated into bits, which are kind of just used in the jumbled sense to kind of like spit out what to do next. It's hard to go in and see that jumbled sense of bits in whatever and make changes to kind of tell it that something's wrong or understand why it made the mistake. It's much harder in this instance. Trying to handicap the AI race between Waymo and Tesla is difficult, says Anthony Lewandowski, who co-founded Waymo before leaving acrimoniously for Uber. Now head of a self-driving tech company called Pronto, he believes that Musk's goal of releasing a fully autonomous driving system in a year isn't reasonable. Creating a self-driving system of the sort Musk wants will probably require more advancement in the fundamentals of AI technology itself, and isn't clear when those will arrive, he adds. Now, arguably, Decart could help with this. It makes it much more efficient. You could process video and then in turn infer it, inferring being the car streaming its decisions, and then the AI model deciding what to do. That's more so the inference in this context. That could be a good innovation, because it could make it much more efficient to then trade it, or it could do things much quicker, which in the driving context is very important. You need as fast as you could get, essentially, to be able to make sure it's actually safe. The cost of sensors used by Waymo and others, including high-resolution cameras, radar, and LiDAR technology that uses lasers to build 3D images, can add up to tens of thousands of dollars, not to mention the expense of mounting them and processing their data. That's also a big problem with Waymo in terms of them getting it to in full production. Like a single Waymo car costs like $200,000, $300,000 because of all the sensors and radar, LiDAR, etc. that it needs on the car. And so to actually get that down, you just need more efficient ways or cheaper ways to create the sensors itself, because that's where most of the car comes. Minivan is nothing compared to a $50,000 sensor that costs more than the van itself, which is also primarily why Tesla is going with cameras, because if they want to sell the cars at a profit and have all those sensors, it's near impossible to do, at least at the scale or size or quality of sensors that like Waymo and others are producing. So yeah, and then they talk about it here, but Tesla's vehicles only have cameras and computing hardware that is generally more modest cost-wise than a Waymo vehicle. Tesla isn't entirely ignoring more sensor-focused approach for self-driving AI technology. Andrew Karpathy, a co-founder of OpenAI, who also headed AI at Tesla from 2017 to 2022, has said that Tesla is using a small number of vehicles that drive around and use like a Waymo-like suite of onboard sensors to create the Tesla driving system's maps. He said this enables Tesla to use some of the same rich data that Waymo and its competitors do, and then deploy that AI on its regular vehicles that are far cheaper to produce. But having this small unit of Waymo-like vehicles somewhat undermines Musk's claims that the data from Tesla's customers' vehicles is sufficient. Whoa! Yeah, see, I mean, there's no sound here, but like this is essentially what I'm talking about, like I just don't see this happening with Waymo. Now there's less Waymo cars, so there's less chances, for this to be happening, but still. Tesla owners like to document their use of its technology. and they have posted a great deal of evidence that undercuts the argument that its vehicles can operate safely with only cameras. I follow several like YouTubers who all they upload is like them going through difficult situations in like the Bay Area, or like hard roads in like LA and New York, like large cities, which is obviously like arguably the hardest for the full self-driving to like navigate. And yeah, sometimes it's surprising that they do get through, you know, situations, but like a lot of the time it's just like, you know, it doesn't fully perform, or they have to take over in like weird situations, especially in cities. Now I'm be curious to know where the larger density of it seems like most Tesla owners are more like suburban folks, you know. Very anecdotal, but like, you know, I don't know, like I don't own a car anymore. I sold my car and I've been doing fine like in the city. Like I could walk to most places. I think most people who live in large city or embrace more of the city life kind of have similar feelings, and they just don't even own a car. So it's like, you know, I don't know. I guess I'm trying to make a point of like maybe this less people own Teslas in large cities than they do the suburbs. And so, you know, having full self-driving perform better in the suburbs might be sufficient. Might be sufficient to like create a product versus it being, you know, good in the cities where maybe less people own Teslas. I don't know. Tesla's current full self-driving software can drive on most surfaces. Tesla's current full self-driving software can drive on most surface streets and highways, but requires vigilant monitoring by the person behind the wheel because it can make sudden and potential catastrophic decisions. Social media is full of recent videos of such moments, cars attempting to turn directly into the path of other vehicles, blowing through red lights, and failing to stop for a train in foggy conditions. Federal auto safety regulators recently announced that they are investigating Tesla over its full self-driving system has played in fatal crashes. Although, to be fair, I think regulators did rule that this was not Tesla's fault. Like they cleared the investigations. Don't quote me on that. Let me just look. Maybe not. Yeah. Tesla didn't respond to several requests for comments on its self-driving systems. All right, wrapping this up. Tesla's own operating manuals specify its systems can be blinded by direct sun, fog, or other inclement weather. Other self-driving systems that rely on sensors such as radar and LiDAR can navigate these types of conditions. Although LiDAR or radar, one of them does have trouble in things like rain, or just like particles in the air, because it needs to bounce off of things, and like things like rain and other, and you know, stuff in the air can interfere with, you know, it transmitting and then bouncing off the correct objects. Think of police like radars, which they sometimes use LiDAR in that. Yeah, that those aren't fully like 100% reliable in every condition. Tesla's computer vision only approach is never going to work, says Mary Cummings, a professor of computer science at George Mason University and director of its Autonomy and Robotics Center. A longtime critic of Tesla's autonomous driving program, Musk has publicly complained about her. That's funny. Cummings recently served as senior safety director to the National Highway Traffic Safety Administration. I'm sure Elon Musk views them as the enemy, of course, which regulates self-driving tech. She thinks the only way for Tesla to even begin to seriously pursue fully autonomous driving is to change its approach to sensors by adding more. And I agree. I think I do agree with this. I agree with this, or that they are going to have to create a technological breakthrough to get it 100% reliable based just off of the videos and the little sensor data that they have, or they're going to have to start putting sensors in new cars to collect more data. But that's this approach right here. So, and you know, I guess let's look at like the actual, like walking down the chain a bit, the sensors themselves. Innovation in the sensors themselves can support this, because if they get cheaper to produce or are more compact to realistically put them in a consumer vehicle that like won't be noticeable, that could help them. You know, they may lose some margins on the vehicles, but that would be made up for in the data they could get to then use to train the, you know, their AI, their machine learning for full self-driving, which could make them more money in the long run. Excuse me, more money in the long run. So that could be the benefit there. In which we actually just talked about this, Sean McGuire from Sequoia Capital is actually invested in a LiDAR company. These are all those, what was it called? I'm gonna find this. It's related. Very much so. Ah, shoot. Okay, I found it on LinkedIn originally. Let me just go there. Luminar Technologies. Maybe, yeah. Oh, they're actually a public company, which is interesting. So Luminar LiDAR is the first and only LiDAR technology to be included as standard equipment on a global production vehicle. Volvo cars beginning to ship all new X90 to customers. This is exactly it. So, you know, let me finish the article and we'll come back. We'll come to this. Yeah, needs to change its approach to sensors by adding more. Meanwhile, Tesla still needs to get permission to test its vehicles on the road using safety drivers, as Waymo and others have. I think it might be true to get that to a completely autonomous vehicle where it never needs remote assistance. You might need something close to human level intelligence, says Lee. I do not think that's a case for optimism for Tesla, because if you look at the companies that are trying to build that, it seems to me they're still pretty far from it. So, yeah. And then, yeah, going back to this is a break. This is what, you know, Tesla kind of should start doing to get more sensor data. Oh, it's mute. Founder and CEO of Luminar Technologies.
You know, we've done some test vehicles before, but this is the first time they got to actually experience a production vehicle, and it's incredible.
I'm assuming this is it up here.
It's you know, we've driven a lot of other kinds of EVs in the industry, and this truly is something in a league of its own, and kicking off that new era.
Of course, right front and center, you see Luminar LiDAR system. Right,
there you go.
Right at the top of the car.
Here we are, after proving out everything step by
Yeah,
step.
okay.
You know, 8 years later, with the technology.
Speeding this up.
Global production vehicle with this kind of technology, with this LiDAR out on the roads. So,
yeah.
Volvo's been leading the charge in this respect for some time, and now we get to finally have it into the hands of consumers and out on the road. Part of what Volvo has done and what people are now focused on after realizing this was the right path is around human-centric driving, around enhancing drivers as opposed to replacing them. And that makes all the difference in terms of building an incredible business, incredible amounts of value, you know, for the consumer and for the company. So it's incredible to see the culmination of nearly a decade worth of work together in creating this LiDAR technology to go onto production vehicles, taking the industry out of R&D and finally bringing it into consumers' hands, into the real world. Volvo's been leading the charge on this, and it's an opportunity to really start changing the world together, just as they have with other kinds of breakthrough modern safety inventions they've done in decades past, doing it exactly again by leading the industry with this next generation LiDAR technology. We're so happy to have Volvo as an incredible partner today, and looking forward to continuing that in the future as we innovate together.
So this is what Tesla and even Waymo, they need more affordable LiDAR systems. Now, this one may not be up to the needs in quality of what they need for self-driving. Yeah, they're just standing by the car. This may not be up to the quality of what Tesla and Waymo need for like data or LiDAR or LiDAR. But it's the same concept, Iris LiDAR, built from the chip up, is a high-performance long-range sensor that unlocks safety and autonomy for cars, commercial trucks, and more. Sentinel features Luminar LiDAR, perception software, HD mapping technology, as well as control and planning software that enables proactive safety. And also, it could just be marketing. Like, it seems like they're kind of selling a bit more full package that, like, a car manufacturer could just kind of install and they don't have to do a bunch of this in-house. Like, this, I mean, it could be different. Oh, look, really right here. Robotaxi. Mobileye. Yeah, Mobileye's Intel. Owned by Intel. Interesting. Trucks. That's it. Oh, plus trucks. I guess they're in that. Volvo. SAIC Motor, smart electric vehicle. Oh, Chinese vehicle. Polestar. Polestar's a Tesla competitor. I've seen them around. But I guess like this EX90, like how much does this cost? This vehicle probably costs $100 grand. $81 starting. Like high end. But not to say Tesla can't do the same thing. Like they, their Model X, or I don't know, they have several cars that are, $80,000+ to cost, and like they could install these on those. But Tesla has a bigger company to run. Like they need profits. Dang, this thing has so many seats. They need to see profits immediately, and they can't just keep taking losses to like in promising future results, even though he's kind of already doing that now, but to a bigger extent. So yeah, it's interesting. I just think it I think this just relates to what Decart is doing. Like there has to be some shared benefit here, considering like it just seems the pattern seems very similar. Let me see. So there was this another New York Times article. Oh no, this is, I already actually talked about that a bit, but bro, they take that. But I can't scroll down. U.S. regulators reject them, and yeah, this is. U.S. energy regulators rejected an amended interconnection agreement for an Amazon data center connected directly to a nuclear power plant in Pennsylvania. Filing showed Friday. It increased the capacity of the data center located in the site of Talon Energy's Susquehanna nuclear generation facility could raise power bills for the public and affect the grid's reliability. And that's what's going to happen. These for-profit power generation companies are going to go where who is going to pay the most. Big tech could pay them much more than a consumer can. And to make up for, increased usage, they're just gonna pass on the cost to consumers, as most big corporations do. As big tech races to grow data centers needed to expand technologies like generative artificial intelligence, locating centers directly on its power plant sites has become an attractive option to power up. This is exactly what Elon Musk is doing with his XA on Tennessee, where he strategically acquired this data center warehouse right next to a natural gas pipeline, so he could essentially tap into that to create a huge cluster for training AI, which is a lot of compute. Co-location agreements of the type presented here present an array of complicated, nuanced, and multifaceted issues, which collectively could have huge ramifications for both grid reliability and consumer cost. And I think the grid reliability is also like a bigger concern, because our grid is outdated. Like, it can't, we need to actually increase or improve our actual grid before we start turning on a lot of these new power plants or data centers who are going to kind of be taking a lot of the energy or producing energy, because our grid needs to be able to handle it. It's very outdated. I'm sure there's some efficiencies and innovations that could be created there. But big tech though, like right now, they're definitely going to try and take the shortest in the cost efficient path forward. Nuclear energy, I'm sure in terms of cost per generation wattage generation, it's very dense compared to solar, wind. Also, it's consistent. Power generates 24/7 essentially. And it's arguably it is clean. It's clean energy. There's the waste, but nowadays the waste itself can be used to generate power and recycled quite a bit. And I feel like, the waste is actually not that big of an issue. But yeah, it is interesting. I'm not going to talk more about this because I think I'm going to end it here. But yeah, it was good stream. I talked for a long time about this, about the Decart AI. I had a lot of thoughts on it. I thought it was, interesting in relating the pattern to other parts of machine learning and AI that have kind of been coming about. And I'm interested to see if there's any innovation in the video game or entertainment space, because I'm bearish on that front. And yeah, I think that does it. I'm kind of over earnings. I know there's earnings, but I don't know. I just think it's not that entertaining on stream. I just rather kind of share stories and kind of interesting tech. Every Monday I'm going to try and do a deep dive like this on a single company or a startup that I'll write up over the weekend and do some research on. But tomorrow's election day. I don't know what my plans are. I'll probably just go through the news. I was thinking about doing election coverage, but it's just outside of what I want to kind of do on this channel. Even though I'll be following it closely. So yeah, I might do it lightly, but we'll probably just talk through some news. I have a lot of topics I still want to go over. There's some cool stuff coming out. I may even cover another startup tomorrow. Non-AI. I want to try and just do more emerging tech in general. Not necessarily just AI. I know I even focus on AI, but a lot of news and a lot of movement around AI right now. Still, so yeah, I want to move outside of just talking about startups. The other company I was considering actually was this company called Overland AI, and they're essentially self-driving, but for off-road vehicles, like a Polaris or a quad. They're training and self-driving for that kind of context, which I thought was interesting. But I may still cover them, but I'll find things outside of AI to talk about that are still interesting. Yeah, thank you for watching. It's more interesting. Okay, good, cool. Yeah, I want it to be interesting, as even though if I talk about AI, I want it to still be AG applicants. Yeah, exactly. And I think they were selling more towards defense even. Like that was like their big like putting it in like Humvees and shit. But yeah, so thanks for watching. Thanks for showing up. Appreciate it. Back tomorrow, 8 a.m. usual. And yeah, make sure to go vote or register to vote. If you're in California, you can still register to vote up till, I think you do it at the polling booth in California, but send in your ballots. Yeah, see you tomorrow, 8 a.m. Thanks for tuning in. I got a new screen for this. Hang on. There we go. See ya. Thanks for showing up.